Alright, so this is the final project. So the game object lifecycle, we're going to start off by visiting the old problems. Game object lifecycle is covered with our pools and factories. We can recall objects between scenes it's deleted, so everything works there. The scene class, as we can see, is very bare bones. We only have these pass-through functions. All of the managers take care of all of the more nitty-gritty details. Uh, for example, we have the initialize function, which the user can override, draw 2D, scene end, and then these functions as well. But for the most part, these are pass-through functions, as you can see. The camera manager, quickly visiting that. This was in the previous, in last quarter, but not much has changed. We have a default cam, default 2D, a God camera that we can use whenever we want. I've shown it tons and tons in previous sprints. I'm not going to be showing it in this current one because nothing has changed there, and also um, the game has a camera that follows the player, which we set. So none of that's needed. Time manager, we have many objects that are requiring time. For example, the player, the bullets. We're using time quite a bit, so everything's good up there. And we've already covered the God cam. So quickly, we're going to go over the collisions as well. So yes, quite a bit has changed. Within the collision volume, this is the base class. We declare we have 4 declarations for all of our inherited types because we're going to need them for the intersect computation. Now, before we go any further, you might notice that these fancy new functions are lacking a little something. Uh, I have a rather nice. I was planning on doing my documentation today, but it's rather late. I don't want this video to be late. That would be really bad. And also, while I was debugging, I came across a very nasty bug that is still in the game. Two, actually, neither of which I could fix in time. I was trying to get that done, and documentation just did not go through. So sadly, we don't have much new documentation. With that out of the way, we have intersect computations for all of the inherited functions. This is so that we can use the visitor pattern here, as we'll see when we go in later on. So the AABB, again, we have the compute data. We can either pass in a model and a matrix, or we can just pass in a B-sphere and it will extract the data through that. Alternatively, we can set the data with 2 vectors, a minimum and a maximum, and it will also set itself up according to those vectors. Debug view is for debug purposes mostly. Then we have intersect requests and compute, again part of the visitor pattern. We have collision volume box, which is basically just the parent for AABB and OOBBs. AABBs and OOBBs, not two O's. This is just having all of the data that they both need to share, and then it also has accessor functions to get all of the information that it has. The OBBs are very similar to the ABBs from the header file. We have compute data. It does not have the same set function, these setting options as the AABB because it doesn't need it. And then we have all of our requests and computes. Stepping into the CPP files, just as a quick look, we can see compute data and set data are fairly similar, and then this is all of the visitor pattern. This is all of the setup. The OOBBs, the collision volume box actually doesn't even have a CPP because the accessor functions can all be declared within the header pretty easily, and then everything else is a virtual function that is overridden within its inherited classes. The CPP for the OBB is much simpler. since most of the information that we need is already available to us within the model itself. So that's the collision volumes, and I'll be going more in depth on the collision and whatever is next on the checklist in the next video.